Alright, this is another MCA lesson for 8th grade, and one thing that we saw on the MCAs was trying to figure out the distance between 2 points on the coordinate grid. And we have the power to actually figure this out already, and most of the 8th graders saw this today, but this will be a nice little review for you. To figure out the distance between 2 points, like I said, we already know how to do that. It's just that we have to set it up a little bit. Okay? Alright, there are actually 2 ways to do this, but I'm only going to show us one. Okay? The 2 ways to do it actually relate from each other, and they stem from the same formula. So this is the first thing that we saw today. To find the distance between this point and this point, we know we're looking for the shortest distance anyway, would be right there. But we do have another way to get from point A to point B, let's say. We could go around, maybe take a straight path like this, and then from here go straight up. We have a lot of different ways that we can get to from A to B. We could do a lot of different things. Whenever they ask for distance, they're looking for the straight path. So we want to figure out this distance right here, okay? But what we see happening is we now have a triangle, and we have a very special triangle. It is a right triangle, because we have a 90-degree angle right there. And we have a special thing that we can do with right triangles, and it is actually the Pythagorean theorem. Okay? So we had a triangle like this, and we've learned this before. We have 3 sides. We have an A and a B for our legs. And the hypotenuse is always the slanted side, or the one opposite our right angle. That is our C. And our equation is A squared plus B squared equals C squared. Alright, this will be the only example we go over. Well, if we have time for another one, we'll do it. But all we need is two of our legs, and we need to know how long they are. And we have that, because what we can do is count each unit for our legs, and then we can plug them into this formula and figure out our distance this way. So with our triangle, our hypotenuse is always the slanted side. That's C. That's the distance we're trying to figure out. A and B can interchange. It doesn't matter. C is the one that's most important where it is. But let's just make this A, and we'll make this B. Now let's count and see how many units long we have for side A. We've got 1, 2, 3. So we have A equals 3 units, and for B we have 1, 2, 3, 4. Alright, now what we can do is plug those into our formula, which we've gone over this before, so that's the part we know. And now it's just like something we've done before, and it's not too difficult, as we found out today. So we plug in 3 for A, that's 3 to the second, plus B, which we said is 4 units, so 4 to the second. That equals C to the second. 3 to the second power is 9. 4 to the second power is 16. That is still all equal to C to the second. 9 plus 16 is 25. That equals C to the second power. Now, at this point we have 2 solutions here. We know that 5 times 5 is 25. Remember, we want to do the square root at this point. So if we square root, we get 5 equals C. Alright? We also could have negative 5 as a solution, because negative 5 times negative 5 also gives us a positive 25. But we're talking about distance, and we can't have a negative distance, so we're going to stick with the positive answer for this one. So C would be 5 units for the distance. Alright? So from here to here, it is 5 units. And that's how we would figure that distance out, using the Pythagorean theorem. And in fact, finding the distance between 2 points is the same strategy each time. So let's look at another one quick. I do want to show another one, because this one came out nice. Came out to 5 units. But that's not always going to be the case. So what we'll do is throw a weird example up here. Use this coordinate system, and let's put a point, let's say here, right on the origin, and we'll go right here.
Mamie Stanton, Noel E. Betcher, and Logan Moss to the office. Mamie Stanton, Noel E. Betcher, and Logan Moss to the office, please.
Alright, not my best line, that's okay, or segment I should say. We want to figure out that red distance, that straight path right there, and what we can do is set up a triangle again. So we go over 2, and up 3, it looks like. So we've got 3 and 2.
We need our assignments.
I thought you said you already had them.
I know she does.
Alright, well I gotta finish this, so sit tight for a second.
Sorry.
That's okay. You're on my video now, so say hi.
Okay.
Okay, so, sorry about that. We've got a 2 units long here and a 3 units long here. And we've got, this side would be our C again. That's the distance we're looking for. And we just plug in what we know. So we can call this B and A if we want, or A and B, it doesn't matter. So let's just say B, we'll call this A. That's fine. Alright, so A to the second, or 2 to the second, plus 3 to the second, which was our B, and that's equal to C squared. And everything's the same now. 2 to the second power is 4. 3 to the second power is 9. That's equal to C squared. 4 plus 9 is 13, and that equals C squared. Last step, we square root. We pick the positive one. We don't know the square root of 13, but that's okay. You can either get a decimal for this, or you can just leave it as square root of 13 units. Alright, so we do get an irrational answer, but that's okay. We can do that. We know those are real numbers, and that is in fact a real distance. Alright, so that is the gist of finding the distance between 2 points. Thanks.